So let's move on to the next topic. Let's talk about safety and security. Our next speakers are Rajeev and Balaji from NXP and Garrett Motion. Rajeev Roy works as a strategic innovation architect. He works on Ethernet product and IP definition, and therefore very close with OEMs and tier ones to collect requirements for their next products. He's also contributing to Open Alliance and IEEE for the standardization process. He holds 2 master degrees, one in physics and one in optoelectronics and optical communication. Further, he received a doctorate in telecommunication from the University 20 in the Netherlands. Balaji Arumugam is the Director of Engineering for Connected Vehicles and Cybersecurity and Diagnostic Software at Garrett Motion. Like Rajeev, he is responsible to collect requirements for the customers and standardization bodies to define their new products. Further, he's responsible for the product development worldwide, and he holds also a master degree in mechanical and control engineering from Purdue University. Gentlemen, floor is yours.
Quick overview of how we will structure the presentation. I know there have been some presentations on the evolving network architectures, but that kind of is important to reiterate why security might be a challenge in some of the cases. Of course, like with everything, to see the effectiveness, we need to have a context. So we will briefly go into setting up context, what we mean, how to parameterize it, so basically to have some yardsticks there. And we will view it from different angles, like what does it mean to secure interfaces, what does it mean in terms of securing the domain, network, and finally the infrastructure. At this point, Bala will take over. He will explain a bit about how network intrusion detection prevention systems are implemented, what are the limitations thereof, how effective that might be, and finally we come to the conclusion of our presentation. Now this view is something which has come across in some of the presentations earlier. Quick summary here, without spending too much time. Generally, it is accepted that the trend in vehicle architecture is towards the so-called zonal paradigm, as it's called. There might be different flavors, and in general, in most technical sessions, you come across some diagram like this, where it goes from the traditional domain-based to more what would be considered a zonal. Now there are different flavors to it. Some tend to be less zonal, and some tend to go to the extreme right, where you see it's completely centralized. Now the reality lies somewhere in between these different figures. Now why this is important is, from a security perspective, basically you're increasing the surface area of attack. That's the first point. Second, which just going back to this slide here. Sorry for messing up the presentation here. But here, if you see, there's compartmentalization. So you do have isolation, which is not the case here. You have more heterogeneity in the network, and that offers more surface area, if you will, from the point of view of attack. Now this slide is something my colleagues from the security who work on aspects like this, they created. So what you see is this seems to, now it works. I hope it's not too loud. For me, it seems quite loud here. Is it okay? Okay, let me give it a shot again. So what you see here on the horizontals are, well, basically the primary fundamentals. You would want to prevent access. So on the horizontals, what you see is the intention to prevent access. That is the first fundamental thing you might want to do from a security perspective. The second, if you're not able to prevent access, is to be able to detect it. And once, if you have detected it, you want to take countermeasures to reduce the impact. And finally, if the damage has been done, you want to try to undo what the damage has been done. So this seems fairly logical to see it in that direction in the horizontal axis. And on the vertical axis, what you see are securing interfaces to get isolation in terms of domain, to get a secure network, secure processing, that means what you do with the data, and finally, secure engineering. Now, this aspect I'm not going to touch in the scope of this presentation, but it just gives you a view of how we can set a framework for the purpose of assessing what security might mean in the context of Ethernet. Now, as you will see, most of these topics might not be that relevant for Ethernet as we see it in terms of data transmission. But some of them, like VLAN, some of them, like authentication, these are relevant for Ethernet. So going across to the next slide here, I'll try to take one by one topic here. Now, if you see the secure interfaces, what is a very common technique adopted in automotive is port-based network access control, or the PNAC 802.1x standard for authenticating MACs. Now, this has been around for quite some time, and now, of course, it takes focus also from the purpose of discussion in MACsec, but just for the timing, if you just leave aside MACsec, if you see what happens in .1x is, the intention is that you're able to authenticate, so you can avoid some of the standard pitfalls like to prevent the man-in-the-middle attack or evil twin proxies kind of stuff. And the expected requirement is that no traffic flows till the authentication is completed. Now, from an Ethernet angle, if you want to see how effective it is, what comes to mind is what can go wrong with these kind of things. Now, we're not trying to question the aspect of 802.1x, but the potential threats are that when you allow a certain type of traffic, this traffic opens up the possibility for denial of service kind of attacks, because then if you're not smart enough to allow only EAP messages, the ones which are used for authentication, it can lead to overload of a processor, for instance, when that is the typical DOS kind of attack that can take place. So the question is the effectiveness of that, and again, not questioning the effectiveness of the .1x mechanism itself, but what it means for Ethernet is how can you identify different types of streams? Is it regular multicast traffic, or are these EAP messages? And if at all you have opened up the port for exchange of EAP messages, can you rate limit them such that there is no subsequent denial of service attack? So these aspects are something beyond what you might want to consider from a .1x perspective. Now, the second one is secure domain isolation. Now, if you see VLANs come to mind, logically that is the case, and that in automotive is no different from, say, enterprise or LAN networking. And VLANs, as the name suggests, are intended for domain separation. But my impression is of VLANs, the way they are used in automotive, is to give a sort of a tag identifier. In that sense, it is a VLAN, as would be in LAN networking as such. But here, the intention is to have that sticker on the frame saying, yeah, this one is an ADAS traffic, or this one is an IVI traffic, or this is a TCU traffic, to have that distinction. So in short, it is used for domain isolation. But the main concern here, if you see the expected from a requirement perspective, what comes across from many OEMs is it good enough to get isolation between secure and non-secure domains? A short answer there would be yes, unless there's a malfunction. So the question is, what are the potential threats thereof? Is leakage of traffic across VLANs. Now, can that happen on paper? No, it cannot, because a VLAN is not supposed to leak traffic across, at least with a layer 2 action. But practical implementations are such that if the switch is not robust enough, has it been validated well enough that that leakage doesn't happen, even when it is not intended to be so? Now, one of the things which, at least in my experience dealing with tier 1s and OEMs, is that the layer 2 people, networking people, by and large, my impression is don't talk that much to the layer 3 networking people. There seems to be a large gap between what a layer 2 network is meant to look like and what a layer 3 network is meant to look like. Now, one proposition here would be that you do consider layer 2 isolation with layer 3 isolation. So layer 3 isolation means subnetting. Layer 2 isolation means VLANs. But there's a very elegant way of defining VLANs where you can define a VLAN, and within that VLAN, a private VLAN, you define sub-VLANs such that you can ensure an additional degree of isolation. And this is not talking about double tagging. So this basically means that you have a private primary VLAN and you associate secondary VLANs such that within a subnet you can get further degree of isolation. Now this sort of a synergy at least would give an additional degree of isolation across the different domains. Now, securing the network, what comes to mind is streams. The simple reason is when you can identify traffic of a certain sort, you can do what you want with that as a consequent action. Now, QCI is a very well-respected TSN standard, which is used for good reasons in the classic TSN sense, but it also is an important tool to be able to implement any sort of IDPS system that you might want to do. Now, potential threats here is when you want to implement any sort of an IDPS system, you also want to monitor it. And if you want to monitor it, typically you might have overriding. Like, to give an example, a typical action of a VLAN might be to drop a frame if the frame doesn't belong to a certain VLAN. But from an IDPS perspective, I might want to monitor that specific frame to know why a certain action is happening. And that can lead to potential loopholes. So the other thing is, of course, like how many rules can you create? Now, there is always a trade-off decision whether you want to make stream-based rules versus, let's say, regular bridging rules. The question is, how many rules can you create? So these are things which eventually determine the effectiveness of any sort of an implementation. Now, this is a whole topic in itself, so I think I will try to skirt through it pretty fast, is MACsec. Now, MACsec is a lot in discussion now. Again, not to question the effectiveness of MACsec per se, but how is it exactly implemented in the context of Ethernet? Like many MACsec implementations, so the biggest threat that you see, one might see there, is that your private information is compromised. That is something you do not want to do. And typically the kind of switches that we make, we do not harden it against physical attacks. So if it was to be hardened, that just makes the device more expensive. So what we try to do is to not store secrets in a switch kind of device, or to have it for the time that it is absolutely relevant. That means that once the process of MACsec is ongoing, even if a hack happens, it's not relevant enough or it doesn't scale to a fleet attack. Now, the biggest concerns here, or to see how the effectiveness of it is still an ongoing discussion. So when you see there is, with the incoming of multi-drop systems, the question of how MACsec should be defined is still open. Right now, it's currently not defined. The other aspect which increasingly comes up is the implementation of end-to-end MACsec. Now, what my take there is to replace the IPsec there, or to complement it, whichever way one wants to see it. Now, point-to-point MACsec is normally not that much of a concern. But the moment you start to go end-to-end MACsec and you want to implement in a switch kind of device, you can scale up the resources tremendously. And the question is whether that's relevant for a switch kind of device or not. And that, again, determines how effective it would be from a security perspective. at the end of the day, a switch has to do what it has been configured to do. And this comes in the angle of secure infrastructure. That means typically what comes to mind is secure boot. Now, per se, it's not about storing secrets, but it's making sure that you have the right firmware or right configuration running what you intended to load in the first place. Now, this, again, falls a bit in the line what I've just mentioned earlier regarding MaxSec is, what are you holding any secrets in the switch device? Does it require physical hardening? Can it, the main aspect is, even if you have implemented secure boot, can it be that you can roll back to get to an older version and boot with that device? Do you have a chain of trust implemented? Do you have version numbering implemented? There are several different aspects you might want to consider when you talk about secure boot. But this is typically how securing the infrastructure is done. Now, I'll end with this slide before handing it over to Bala. Now, from a security perspective, what is important to understand is what is the benefit you can reap. By and large, what this slide shows on the horizontal axis is that remote attacks tend to pay more dollars back to a hacker. That's because they tend to scale easier to a fleet attack. Local attacks, well, if the ECU is hardened, of course they can happen. You can hack one car. Nothing prevents people from hacking one car. But the question is whether it scales or not. So a general rule of thumb is that if it is a local attack, the exploitability of that attack is less. But if it's a remote attack, the exploitability is high. So typically what we try to do in Ethernet within code security is to try to make sure that it doesn't scale as a fleet attack. Any vulnerability that you leave should not scale as a fleet attack. And with that, I will hand it over to Bala.
Thanks, Rajeev. All right, so I'm going to introduce you or make you aware of the Ethernet IDPS, one of the security solutions which Rajeev introduced. I have the challenge to keep you interested before the lunch, so I do understand. All right, so network intrusion detection and protection system, right? So basically it's modeling off a known behavior of the network and alert on violations. And it could be a software, or it could be a hardware, or it could be a combined solution, right? What are the key features typically, right? So it could be a simple rule-based. It could be a rule which is based on a vehicle context. It could be even using a vehicle accelerator or detectors. And it could do deep packet inspection. As I mentioned, it could do a rule-based, and we could even apply machine learning, right? And also, the end result of the IDPS always becomes an alert or an information log, which gives more context on what's happening. And a VSOC typically, as shown in the ecosystem there, typically has the challenge to put pieces together to make sense of what's happening. What it does, right? So I kind of touched this point. So it's, the main purpose is to detect an unknown or an abnormal or an invalid traffic, right? And also attacks, right? Its job is to also find attacks. It could be DOS, it could be man in the middle, right? It could be harmful patterns, right? Teardrop, and many more. And also, as I said, reporting anomalies and also prevention, right? So we will talk a little bit more. And Rajeev touched upon the switch, right? Application of a switch. But why does a switch is not many times enough, right? A switch, of course, cannot do an inspection of a payload to identify a threat, right? It cannot detect if a device from a network is corrupted, for example. It cannot monitor and prevent malicious activity between two devices, for example, right? So it has few limitations. So I want to introduce you in this slide a generic architecture of a network IDPS, right? Typically, it would have a DAC or an acquisition engine where it's filtering the protocols which it wants to inspect. and it would have an engine where it runs the algorithms which are intended to run the algorithms on those protocols. And then we kind of touched the reporting engine, which is delivering a package or a log which has some key information, and then a protection engine, right, which basically can prevent an active and ongoing attack, for example. So in this slide, I want to talk about different methods to deploy and different configurations of network IDPS. From deployment methodology, it can be a centralized, it can also be a decentralized, right? And configurations, it can be inline, and it can also be monitoring only, right? Of course, there are pros and cons of each of those types. I'm not going to deep dive in those in this presentation, but I just want to introduce you. There are various ways to deploy and also various ways to configure. And also, since we talked about the switch, we also can take advantage of the switch by deploying IDPS on a switch or a part of the solution on the switch and utilize the processing capability, right? So it can enhance the overall capabilities of the IDPS solution, and it also has advantage of implementing the protection functionality, which we kind of talked about. Is network IDPS perfect? I would say no, right? I think many of you will agree. But if we resolve these things, it could be a much powerful tool, right? So obviously, it depends on the hardware capability, how many algorithms you want to run, how much optimization you can take advantage of the hardware. Of course, it needs constant updates. And of course, it could have the high potential to be creating a lot of false positives if the data used to model was outdated, right? Or it was the design was not stable at the time of development, right? So I'm going to hand it over to Rajeev for the summary.
Thanks, Bala. Short message here is there are enough tools to realize security, but to see how effective it is, you need to first have a context. If you don't set a context, the aspect of talking about effectiveness loses its meaning. It's a bit like if you have a hammer to strike a nail and you're skilled enough to use the hammer, that works well. But if you're not skilled enough to use the hammer, or the hammer is not properly made, it can lead to consequences that you might not want to have. So from a security perspective, if you see typically what Ethernet does and gives is a framework. It addresses a small aspect in a big jigsaw puzzle. It cannot solve all the problems. But what it does, you need to be able to make it effective for the purpose that you intend. And that's a bit the short message here from the presentation. Thank you for your attention.
So thank you for this wonderful presentation. Are there some questions? I think everyone is hungry now.
Yep.
So I do have a question. Suppose zonal architecture. Where do you think is the IDPS best location? Vehicle computer? Is it a zonal issue? Where is it best?
Yeah, I would
or
say
both?
it's a distributed, yeah.
Is it distributed?
Yeah. It's
okay.
Not, that would be a very myopic view to say, no, everything is in center. I think if you can address it away from at the first point of contact, that's always better.
All right. Further questions? Seeing none. Everyone is hungry now. Okay. We will meet back at 2 o'clock. The lunch is at the second floor. On your badge, you have a ticket for the lunch. Please enjoy the food. And also, at the break, you have possibility to visit the exhibition area. Thank you so much.